Hello again, everyone. So now we're going to look at how we calculate half-life. Now, there's a couple of different ways to do this. You can either use a graph or you might have to do a calculation. And when I say a calculation, I don't mean anything extravagant. I mean using fractions or percentages just to try and work something out. Now, when I say half-life, I do literally mean half-life. So it's how long does it take for a sample to lose half of its unstable nuclei. It's dead straightforward. It'll be a little bit baffling at first, but I'll go through a few examples and then you've got 2 task sheets to work through. Please take your time with them. You've got obviously from when the session starts, but watch the videos, make your notes, and then attempt the tasks. You've got until 3 o'clock. And as usual, I'll try and get that marked and back to you and discuss any mistakes. And the Zoom session will be open as well, so you can ask me any questions if you've got them. Anyway, so 2 different ways you can do this, really. If you're looking at a graph, so if you've plotted the graph, you will have seen in the last video, I drew that graph out very, very quickly. So I'll just sketch a super quick, dodgy graph. So if this is your number of rolls of a dice, say, for example, and then this is the activity. If, for example, that activity starts at 1,000 and you've got 0 down here and rolls, say it's 20 or whatever, and then your graph goes like this, okay, and this little sweep, your half-life of this sample is going to be where the activity falls to a half. So the total activity was 1,000, so half of the activity is going to be 500. So if this was 500 here, I want to know what the activity is, or after how many rolls, or say for instance if this was days or whatever, or minutes or hours, it could be any type of unit, it doesn't matter, as long as you can get to the half that activity. So if the total activity was 1,000 and half of the activity is 500, all I do is go straight over to the graph, straight down, and then I get my number here. So say for instance, say if that was 5, okay, so after 5 rolls, my activity is halved, all right, and that is literally a half-life. So the first half-life is 5 rolls, okay, and that's it. That's how you work out half-life. Now, if I said to you, I want to know what it is, the activity is after 2 half-lives, well, I half it and then I half it again. So what's half of 500? Well, half of 500 is 250, and I just do the exact same thing again. Go across, go down, and what you should find is that it's consistent. So if one half-life is 5 rolls or 5 days, hours or whatever, that should technically be 10. So 2 half-lives should be 10 rolls, and then 3, so 125, and then that would be 15, and then so on and so forth, and it goes on and on and on and on, on and on and on, and you can keep going, which should be consistent. So half-life should be consistent, okay, it should match up. So it's always a constant value. So half-life is always constant. Okay, simple as that. Half-life is always constant. So there's 2 different definitions of half-life. They're in the PowerPoint, so I'm not going to write them down because it will just be boring if you're just going to see them a second time, but I am going to read them out. So your 2 definitions of half-life are either the time it takes for the number of nuclei of the isotope in a sample to half, or the time it takes for the count rate from the sample containing the isotope to fall to half of its starting level. I'll say them again. The time it takes for the number of nuclei in the isotope in the sample to half, or the time it takes for the count rate from a sample containing the isotope to fall to half of its starting level. They're both in the PowerPoint, so you can have a read of them and you can work it out from there. Now, that's using a graph, okay? if you are given a wordy question and you are told to work out the activity, then it will look a little something like this. And again, this is in the PowerPoint, so you can watch the video, but it's in the PowerPoint as well. And it will go like this. So if I give you a sample and it's half-life, I'm going to start being really lazy and I'm just write HL because I'm a chemist and we abbreviate everything. So the half-life is 3 hours. Okay, so I know it's 3 hours. That's an S, not a 5, which is really dodgy. So the half-life is 3 hours. I want to know, how long will it take for this sample to fall below 12.5% of its activity? So how long will it take for the activity to go 12.5%? Okay, below that. So I'm going to write out some steps and we're going to fill in the half-lives and we're going to fill in the hours it's going to take. So obviously at the beginning, I've got 100% of my sample. Okay. After the first half-life, I'll have 50% of my sample because it's going to lose 50% of those nuclei. After another half-life, it's going to lose another 50% again. So 50% of 50% is 25%. And then I'm going to lose half again. And oh, look, I'm at 12.5%. Okay, so now what I need to do is I need to fill in these gaps. So this first jump here was 1 half-life. And 1 half-life was 3 hours. Okay. This jump here, this is 2 half-lives. All right, so if we've gone up another 3 hours, then 3 and 3, we've now got 6 hours. Because like I said there, it's constant. This one, 3 half-lives. It's gone up another 3 hours. So it's 9 hours. Okay, so it's going to take 9 hours for this sample to fall below 12.5%. Okay, and that's all you've got to do. So if it gives you a percentage, write out your percentages, half them each time. Start with 100, half it each time until you get to your destination. Okay, so you get to where you want to go. And then every arrow is a half-life. So write 1, 2, 3, 4, however many it is. And then fill in the hours, the days, the rolls, the minutes, the seconds, whatever, across the top. And make sure that you stay constant. So if this was 1, then that would be 1, 2, and then that would be 4. Okay, so just keep, sorry, no it wouldn't, I'm lying, it'd be 1, then 2, then 3. Okay, if this was 2 days, let's say 2 days, it'd be 2 days, 4 days, 6 days. Okay, it's constant. Just keep it going like that. Okay, I'll do a couple of examples of these just so you've got an idea, and then there's another type of example to show you. So I'll just do one more example of this just so you get to grips with what it is that you've got to do. So if we say sample 2, okay, and it's got a half-life of 8 hours. Okay, and I want to know how long is it going to take for the activity to fall below, excuse me, 25%. So I want to go to that 25%. I'm going to start out again, like I said, with my 100% of my sample. It's going to go to 50%, and then it's going to go to 25%. Okay, so I fill out my half-lives, like I said. So 1 half-life, 2 half-lives. How many hours is 1 half-life? Well, it's 8. How many hours must 2 half-lives be? Well, it's 16. So it's going to take 16 hours for sample number 2 to decay and to lose activity below 25%. Okay? And that's all you've got to do. All right, that's honestly all that you have to do with this. Okay? So just keep going with your half-lives until you get to that destination. So obviously after 25, it's 12.5. After 12.5, it's 6.25. And then it becomes 3.125, and it keeps going and going and going and going and going, and you just keep halving it. Basically, you never get to 0. But I can't imagine it will take you any further than I don't know. I can't imagine it taking any further than maybe 6.25%. They're being cruel if they take you further than that. Right, so another example of this, which is a tricky one. It's very, very wordy, so you've got to take it a little bit at a time. So another type of example is when they want to know what like proportion is left of it, so like how much of it is left. So they will tell you what the half-life is, and they'll tell you what the age of it is maybe, or like how much of it is left. And then they'll say, sorry, not how much of it is left, but they'll tell you the half-life of it, and then they'll tell you the age of it. And then they'll say, right, well, how much must be left now? So how much could possibly be left now? That's where it gets a little bit more complicated. Don't stress too much when you see these examples, because I can sort of guarantee that you're going to say, I've no idea like how to work this out. I'll do an example. I'll show you what happens. And then I will let you guys have a go of some examples. There are loads and loads of examples in the PowerPoint. I'm going to identify them as tasks. Don't worry if you don't get through them all, because we're going to do this on Friday as well. So just have a little go. But for now, I'll show you this example. You're going to think this is dead baffling, but don't worry about it. Like I say, we're going to do it on Friday as well. So another example is this. So if we've got carbon 14. Okay. Carbon 14 has got a half-life of 5,730 years. That's a very long time. Okay. Scientists dig up a skull. I'm not going to try and draw one because I can't draw to save my life. You all know that. So there's my skull. The skull is about 28,000 years old. Okay, so it's about 28,000 years old. What they want to know is what is left of the carbon 14 in this skull. Now, just to put it into context, carbon 14 is used to what we call carbon date material. So if they can figure out like the proportion of the carbon 14 that's present, they can figure out, excuse me, they can figure out the age of the material. So let's have a little look. Right. Oh, I'm yawning. Oh. Excuse me. So we start out with our 100%. Okay. And we're going to go with 50%, and we're going to fill out the details. So one half-life is 5,730 years. Okay, so we know that, well, that's not right, because we've still not hit that. We've still not hit the 28,000 yet. So we go again. 25%. I'm going to run out of space. I'm going to go down the side here. 25%. So it's two half-lives, and that is 11,460 years. So we're still not right. We're still not in the right place. So we go again. 12.5%. All right, three half-lives. And that is going to be 17,190 years. Still not in the right place. So we go again. And we go to 6.25%. Four half-lives. And this time, 22,920. We're getting closer. All right. So now we need to half this again. And I'm just going to do it like this. That is our fifth half-life. And we are going to 3.125%. And this time it's 28,650 years. So now we've hit that target. So it was approximately 28,000 years old. We've hit 28,650. So this is the proportion that's left. So that is the activity that it's reduced down to. So it's reduced down to 3.125% of its activity. All right. Now, that is fine to do it like that, so do it in steps. I would personally be doing it in steps like that. If you want to jump ahead because you've got a particularly mathsy brain, if they've told you that it's approximately 28,000 years old and that one half-life is 5,730, if you work out the like the ratio, the proportion here, it's 4.8. Well, 4.8 is about 5, isn't it? If we were rounding it up, that's 5 half-lives. So that tells you that's how many times you need to half it. Okay, so just half 28,000 5 times. All right, and that's where you'll get to. But that's another way of doing it. Okay, and that is particularly hard. It isn't easy in places. Please don't stress and think, I have no idea what I'm doing. I can't do this. Just take it really easy and use the worked examples that are on the PowerPoint. They break them down into chunks and they purposely make it easy for you. Okay. Try them, have a go. I've put some examples in the PowerPoint, and I will attach a file that says PowerPoint worked examples. So please write your answers in that. Obviously, if you want to upload a photo, that's fine, but I will put a blank Google Docs in there as well. Anyway, that's it for the activity and for the half-life. So I hope that was okay. Obviously, we'll be on Zoom. Be there to chat. Anything that you need, just let me know tomorrow. And yeah, that's it. So happy half-lifing, and I'll see you in the lesson.